Hi, everyone. Next to the NPR button, you should see the NCR button, which is combinations. For example, let's say we have 7 runners in an Olympic race, no ties. And let's say that there are 3 gold medals for the 3 winners. And the runners don't care which of these 3 medals they get, they just want a gold medal. A medal is a medal. Find the number of ways to choose 3 winners among the 7 runners. The number of ways for fate to assign the 3 gold medals to the 7 runners. So we have a pool of n equals 7 distinct runners, no clones. And from here, we're going to draw r equals 3 winners, the gold medalists. But this time, unlike before with NPR, this time with NCR combinations, the order among the winners will be irrelevant. They don't care which gold medal they get. So we take the 7 runners. Imagine that this is their order of finish. 7 factorial is the number of ways to order all 7 runners. Just like before, we don't care about the order among the 4 losers, so we divide by 4 factorial. But this time, we don't care about the order among the 3 winners either, so we also divide by 3 factorial. All these 3 runners get a gold medal. They don't care which one. So that's the formula for 7C3, or 7 choose 3. The number of combinations of 7 distinct items taken 3 at a time. How many ways are there for fate to choose 3 runners, 3 winners, 3 gold medalists out of the 7 runners? So 7C3 is 7 factorial divided by the 3 factorial and also the 4 factorial, because we don't care about the order among the winners or among the losers. 7 factorial is 7 times 6 times 5 times 4 factorial, which cancels out with the thing down here. Okay, 3 factorial is 6. When you work this out, you get 35. On a calculator, remember that's a double division. You're dividing 7 factorial by both 3 factorial and 4 factorial. Or if you find the NCR button on your calculator, it might be in the PRB menu on the TI calculators. You might press in 7 NCR 3 equals or enter, and you'll get the 35. There are 35 ways for fate to choose 3 gold medalists among the 7 runners. In general, here's the formula for reasonable integer values of n and r. NCR, or n choose r, equals n factorial, the number of full permutations of all n runners. You divide by r factorial, where r is the number of winners, and you also divide by n minus r, all factorial, where n minus r is the number of losers. Here's another way to look at it. Let's say that you assign the numbers 1 through 7 to the 7 runners. These are called the bib numbers, the numbers that runners have on their backs. Before the race, they're assigned. After the race, you take a photo. Here's runner number 1 all the way through runner number 7. And we're being kind of rude. We're putting a big L on the runners who have lost and a big W on the runners who have won, the medals. Here's another way of looking at 7C3. 7 choose 3. It's the number of ways of ordering or permuting this word, this fake word, WWWLLLL. How many ways are there to order this word? We take 7 factorial. We don't care about the order among the W's, so we divide by 3 factorial. We don't care about the order among the L's, so we divide by 4 factorial. Again, the answer is 35. That's another way of looking at this problem. Here are some related questions, which also lead to 7C3, or 35. Let's say you're given a list of 7 essay questions in an English class, and you must choose 3 of them to write on. And it doesn't matter what order you write them in. How many ways are there to choose the 3 questions? Well, 7 choose 3, or 7C3, which is 35. Also, let's say that you have a test consisting of 7 questions, and you answer all of them. You're told that you got 3 of the 7 correct. You got exactly 3 questions right on the test of 7 questions. How many ways were there to get 3 questions right out of 7? The answer is 35. It could have been the first 3 questions you got right. It could have been the last 3. It could have been 1, 2, and 4. There are 35 possible triples. Here's a pre-virus question that's related. You have a Halloween bowl with 7 different candies. What's your favorite candy? What? Snickers, Three Musketeers? You have 7 candies, different candies, in this Halloween bowl. A spooky skeleton comes to your door. How many ways are there to give the skeleton 3 candies out of the 7? Order doesn't matter. The skeleton just cares which 3 candies it gets. Well, 7 choose 3 or 7 see 3, that's 35. 35 ways to give 3 candies out of the 7 in the bowl. So these are very useful problems. In poker, let's say you're dealt a 5-card hand. The King of Hearts, the Queen of Hearts, the Jack of Hearts, the 10 of Hearts, and the Ace of Hearts. Are you mad that these cards are out of order? No. How should you feel, actually? If you go to a video poker machine in Vegas, you should feel thrilled because this is called a royal flush. Technically, the Ace of Hearts looks better over here, but the order among the chosen cards doesn't matter. You always have the right to reorder the cards in your hand. That's my idea of a hand. All right, we draw 5 cards from a 52-card deck without replacement. Of course, we're not allowed to copy cards. Find the number of possible 5-card hands. How many ways are there to get 5 cards out of this deck of 52 without replacement? Well, it's 52C5 or 52 choose 5. Hopefully, you can do this on your calculator, but if you have to work it out, 52 factorial is 52 times 51 times 50 times 49 times 48 times 47 factorial. That covers 47 down to 1. And that cancels out with the 47 factorial in the bottom. Because we don't care about the 47 cards left in the deck. Likewise, we don't care about the 5 cards in your hand. So we also divide by 5 factorial. We get about 2.6 million. So, by chance, what is the probability that you get this Hearts Royal Flush by chance? It's going to be 1 over this. In fact, the probability of getting any particular card, any particular hand of 5 different cards among the 52 cards, where the order is irrelevant, it's going to be 1 over about 2.6 million.